Probability is the ratio of favorable to total possible. The sample space is the number of possible. So if we, like I said, we have that bag of, let's say five marbles in it, and there are 5 different colors, and I pull out a blue one, that's 1 out of 5 choice of pulling blue. Now, if there's 5 different colors, there's only 1 of each color, then it's equally likely that I'll pull out a blue one or a red one or a green one, yellow, whatever, because they're all going to be 1 over n. Okay, probability is always between 0 and 1, so it's a fraction. So if there's no chance, that's the 0. Well, then if there aren't any, there's no probability, so we don't really even count that, right? And then 1, well, if every single marble in the bag is blue, and I say, what is the probability you'll pull out a blue one? It's pointless, right? So that's why it's always between 0 and 1, because it's always a fraction. So n over n if they were all blue. And your probability is going to be someplace in here in the middle. Okay. Basically, if your numerator is taller or bigger compared to your denominator, closer to 1, more likely to happen. Closer to 0, less likely to happen. Okay. So to find the probability, we take the number of favorable outcomes over the number of possible outcomes, and then we want to reduce the fraction. Okay. So if we take a die, one single die, if you have a pair of dice, it's dice, and if you have just one, it's called a die. And we want to know what is the probability of rolling a 1 or a 5. Okay, so this is 2 favorable outcomes, right? How many possible are there?
6.
Right, because there are 6 sides, 6 numbers. So my probability is 2 over 6. 2 favorable, 6 total possible, and both of these are even, so I can reduce it by dividing by 2. So my probability is 1/3, 1 over 3. Okay. What's the probability of rolling an even number? How many even numbers are on there?
3.
3, right? So 3 favorable. Still 6 possible. Yeah, so my probability is going to be 3 out of 6, which I can reduce. They both divide by 3. So my probability is 1/2, or 1 out of 2. Okay, so let's talk about, I have, like, if my probability of favorable on the die is 2 favorable, the complement of that is going to be 4, because there's 6 possible. So 4 unfavorable to the 2 favorable. So we have a bowl and it has 5 red chips, 7 blue chips, 6 yellow chips, and 10 green chips. We're going to pick one randomly. They're all mixed up, right? And we're going to find the probability. So first we need to know, what are the total possible outcomes? Yeah. 28 chips in the bowl. Okay. Blue chips. 7 blue. So there's 7 possible blue out of 28 total. 7 and 28 will both reduce by 7. So my odds are 1 in 4. Or sorry, not my odds. My probability is 1/4. Basically, probability ends up getting converted to percentages a lot. So this would be a 25%. You have a 25% chance of pulling a blue chip out. Okay, red or yellow. Well, we have 5 red, 6 yellow, so that's 11 possible. Right? So that's 11 out of 28. Now I can't reduce that. So that's just my answer. Okay. And now, when they talk about complements, a lot of times they put the word not in front of it. Not green. Well, there are 10 green. So how many are not green? 18 are not green. So we've got 18 out of 28. These will both divide by 2. So I get 9/14. Another way to figure out possible outcomes is to do a tree diagram. And what this does is you list your possible options. And then your last column gives the total number of possible outcomes.
What's the first word? Last? First?
Here? List.
List.
Okay, so here's how it works. Okay, you've got baseball caps come in blue, yellow, or white, and then they can either have the school mascot or the school initials on them. So you have color, and then you have design, right? I can get blue with a mascot or the initials, right? So I can get a blue cap with mascot or a blue cap with initials. I could get yellow with a mascot or initials. And then I can get white with a mascot or initials. Now this is not necessarily the easiest or least time consuming way to do this. This is just one way to do this. So I have 1, 2, 3, 4, 5, 6 possible choices. Right? And then if there was like you get blue with a mascot or initials and then maybe there was another option, then you'd add another column and keep going. Does that make sense? Okay, the fundamental counting principle says if you have an event M that can occur in M ways, and then there's N. So M here is the color of the baseball cap, and N would be the design on it. Then you multiply how many by how many. So back here we had 3 colors, 2 designs. 3 times 2, 6. So here we have an ice cream shop. We have 1, 2, or 3 scoops. So that's 3 scoop choices. Okay, 12 different flavors with a V. It says 12 flavors. Okay, and you can get a wafer cone, a sugar cone, or a cup. So that's 3 container options, right? So we've got 3 scoops, 1, 2, or 3. Then you have 12 flavors and 3 possible containers, cones and cups. So if I multiply these together, I'm going to get 36 times 3, which is 108 possible combinations. So if you went and ordered different ice cream every day, it would be 108 days before you ran out of possible combinations of ice cream to order from this shop. Okay. 3-digit password for your logon name. This is why these things work really well. Okay. The password can indicate any digit 0 to 9, but they cannot repeat. Okay, if I take 0 to 9, how many actual digits is that?
10.
10 digits, right? So the first digit has 10 digits that I can choose from. Now, if I've used one of those digits, I can't use it again, so what's my second digit? Or what's my second choice? I have 9 digits. And then if I can't choose again, I've taken one more away, 8 digits. So if I have a 3-digit code that I can't repeat, there are 721 possible combinations. Or sorry, 720 possible combinations. That's just for a 3-digit code. Now, if you're allowed to repeat digits, that's 1,000 possible, right? Because it's 10 and 10 and 10. That's why those, you guys have seen those electronic keypads for cars and doors and stuff. That's why they're reliable. If you only had just 3 digits, somebody would have to sit there and try 720 different possible combinations of digits to make sure that they got yours.
Isn't there like 3 digits on each number thing?
Mm-hmm. Yeah, but so it's really at that point it's 5 digits, but they're also not a 2 or 3-digit code. They're longer than that.
Mom's car, you have to push like the side of the button. You can't even push the whole thing down.
Oh, you have to push the side that the number's on? Okay, so see that, yeah. My odds. Odds are a ratio of successes to failure. Okay, now probability is usually done in percentages, like your probability of this happening is 15%, like the chance of rain is a probability, is 70% chance of rain. That's the probability that it's going to rain this afternoon. Odds are usually said like, oh, 2 to 1, 3 to 5, things like that. So you do the total number of successes to the total number of failures. So the odds of rolling a number less than 3, if we take one single die and we roll it. Well, what numbers are less than 3?
2 and 1.
Right, so there's 2 possible less than 3. So those are my successes. And then there are 4 3 or more. So these are success. And if I roll a 3 or more, that's a failure. So my odds are 2 to 4 or 1 to 2. Okay, here's how this works. If this number, the numerator, is greater than the denominator, these are good odds. If your numerator is less than your denominator, these are bad odds. Right now, this is telling me basically for every 3 times I roll, I'm going to fail twice and succeed once. This is bad odds. My failures are higher than my successes. That's bad odds. You want your successes to be higher than your failures. That's when you have good odds.